Q-qPCR software tutorial, Relative Quantification Analysis. In this video, we will show you how to analyze differences in gene expression for a given sample group relative to a control group using the relative quantification option of the Q-qPCR software. The software uses the Relative Expression software tool developed by Michael Pfaffel to calculate gene expression ratios between two groups. The method is described in the following publication by Pfaffel et al. Intercalating dye run. For this run, the chemistry type is intercalating dye, and the dye is cyber green. Before starting, check that the assays are well defined. Remember to indicate which target is the gene of interest and which is the endogenous reference gene to calculate relative quantification. You can do this in the assay setup prior to starting a run. We used 2 reference genes for this run. The sample editor must also be annotated properly to allow for relative quantification analysis. Ensure that the names are properly added and that the replicates have the same characters. The type should be unknown for samples being investigated. We recommend using no template controls and no reverse transcription controls. Importantly, don't forget to add and allocate your groups and link the assays to your samples. Now let's start the relative quantification analysis by selecting the plus button next to the relative quantification in the analysis section. Before we can complete the analysis, we just need to fill in some details in the analysis parameters. The method of analysis, REST, is automatically selected. To calculate efficiency, you can choose an option from efficiency source. You can use a standard curve to determine efficiency. If standard curve is selected, then the software will provide a daughter analysis below to allow you to change parameters associated with the standard curve. Ensure that standards are properly annotated in the sample editor. The cycling option uses the mean efficiency, determined using the LinReg PCR method for each sample. The option Set Value allows you to set an efficiency value for each target manually. This value can be stored in the assay setup. In this example, we choose cycling. Each target used in the run must be selected as a gene of interest, reference, or none. Multiple genes can be used per analysis. The final step is to select the groups we wish to compare. Select the control group and define the treatment group. The calculated efficiency for each target will be displayed next to gene role. The gene expression ratios between the two groups are graphed as box and whisker plots. The box represents the upper and lower quartiles with a median line, and minimum and maximum observations are the whiskers. If you hover over the box, a tooltip will appear with the numerical values for the box and whisker plot. The result table will display the following: the genes of interest being investigated, the treatment groups being compared with the control, the difference in gene expression between the two groups, expression level confidence intervals at 68%, equivalent to a single standard error, expression level confidence intervals at 95%. The hypothesis test P gives the probability that any observed difference between the two groups is due to chance. P-values less than 0.5 are considered to be statistically significant. A text annotation of the gene expression is described as either down, up, or no difference. Multiple groups can be analyzed at the same time. Unlike the other analyses, The samples in the Samples selector for relative quantification analysis are displayed for all targets combined rather than each individual well. This ensures consistency in turning samples on and off. Cycling analysis is automatically paired with relative quantification analysis and appears below it in the navigator bar. We can view the cycling analysis data used to calculate efficiency and the CQ values required for relative quantification analysis. You can change any of the parameters if required. Hydrolysis probes run. For this other run, in which the chemistry type is hydrolysis probes, we make sure to indicate which target is the gene of interest and which is the endogenous reference gene to calculate relative quantification. The sample editor must also be annotated properly. Ensure the names, types, groups, and assays are properly added, and the replicates have the same characters. To start the relative quantification analysis, select the plus button next to Relative Quantification. Select the role for each target and the groups we wish to compare. The gene expression ratio of each group will be graphed as box and whisker plots. Hover over the box to see a tooltip with the numerical values for the box and whisker plot. The cycling analysis automatically appears below relative quantification in the navigator bar. We can view cycling analysis data and change any of the parameters. Finally, save the results table to CSV file format. Or copy the result table data to clipboard so you can paste into another third-party software. In this video, we have shown how to use the relative quantification analysis to obtain the expression ratios of your targets and confidence intervals. For more information about relative quantification analysis, please contact the Quanta Bio team.